Hey guys, it's Mr. Gron. Welcome to the lesson 6.9, curve fitting with polynomial models. This video is going to talk about one of the ways we can determine what type of polynomial best fits a particular type of set of data. All right, so one thing that's really interesting about polynomial functions is that we can take a scatter plot of data and figure out what type of model would best fit that data using what are called finite differences. Now, mathematically, the differences mean like subtracting, right? So how much distance there is between two numbers, the difference between them. All right, so if we look at this table, one important element of this is that the x values, we're not going to really use the x values, but looking at the x values are evenly spaced, so all of the differences are the same. The y values, though, are very different. There's different distances, different differences between them. What we're going to do is figure out, we're going to subtract 10 minus negative 4. Then we're going to subtract negative 4 minus negative 1.4, and so on, and sort of add another row to this table. And if all of those numbers, all of those differences are equal to one another, that would mean that this is a first degree or a linear polynomial. If it isn't a first degree polynomial, we're going to repeat that process and see if the second set of differences are equal, in which case it would be a quadratic, and we'll keep repeating and so on and so forth until we get a row that all of the numbers, all the differences are the same. Okay, so the way this is going to work, again, I'm going to start out with these two numbers here, just negative 10 minus negative 4. This involves a lot of subtracting negative numbers, so remember that negative 10 minus negative 4, that changes it to negative 10 plus 4, right? Now, I'm not going to do that every single time because it's going to be a lot of subtraction in this, so try to pay attention. All right, negative 10 minus negative 4, that is going to be negative 6. Then negative 4 minus negative 1.4, negative 2.6. Negative 1.4 minus 0 is negative 1.4. 0 minus 2.4, negative 2.4, and 2.4 minus 8 is negative 5.6. Okay, so we know it's not a first degree polynomial because those didn't match. Now we're going to do the same thing with the next set. So I'm going to start out 6 minus negative 2.6, and then negative 2.6 minus negative 1.4, and so on to get the next set of differences. All right, negative 6 minus negative 2.6 is negative 3.4. Then negative 2.6 minus negative 1.4 is negative 1.2. Negative 1.4 minus negative 2.4 is positive 1. And negative 2.4 minus negative 5.6 is positive 3.2. So those numbers don't match yet. It's not the second set of differences, so it's not a second degree. We'll check the third degree. All right, negative 3.4 minus negative 1.2 is negative 2.2. Negative 1.2 minus 1 is negative 2.2, and then 1 minus 3.2 is also negative 2.2. All of them match, so it is a third degree or a cubic polynomial. So if we plotted all of these points on a graph and connected them with the curve that fits them the best, it's going to be a cubic polynomial that's going to match this. All right, if you want to pause the video and try this one on your own, see if you come up with the same thing as me. I'm going to go through it a little bit quicker, so when you're ready, unpause and see if you got it right. Okay, so negative 30 minus 15, negative 45, 15 minus 30, negative 15, 30 minus 34, negative 4, 34 minus 41, negative 7, and negative 41 minus 60 is negative 19. Okay, not a linear, so let's go to the next one. Negative 45 minus negative 15 is negative 30. Negative 15 minus negative 4 is negative 11. Negative 4 minus negative 7 is 3. Negative 7 minus negative 19 is positive 12. So it's not a quadratic. Negative 30 minus negative 11 is negative 19. Negative 11 minus 3 is negative 14. 3 minus 12 is negative 9. So it's not a cubic. And then negative 19 minus negative 14 is negative 5. And negative 14 minus negative 9, also negative 5. So this is a fourth degree polynomial, or a quartic.